down to. All right, my friends. We're going to start, and we're going to go back to physics just a little bit, but we're doing everyone's favorite word problems, okay? So everyone's so excited, I know. Now, let's think about this. The title of this is Distance, Rate, and Time Problems. Sound familiar? Guys, when you're doing this, what is the basic formula that I use with distance, rate, and time? What is it? Distance equals what? Yeah. Distance equals rate times what? Times time. Guess what? That equation still hasn't changed from physics. It's still the same one. So let's see if we remember a few things. All right, so let's go backwards. We're going to do easy before we get hard. All right, so what if Mrs. G travels for 2 hours at 50 miles per hour? How far have I traveled? What would you do? So distance equals what? Rate times time. What is my rate? All right, so 50 miles per hour is my rate. What's my time? All right. That's 2 hours. Now, one thing you double check is my time and my per hours, do those match? Because if not, do you have to convert them? Yes. So they match this time. So we just plug it in. Our rate is 50. Our time is 2. How far did I end up traveling? And we label because we got to make sure people know. Now, so when you don't really abbreviate miles. It's one of those that's close enough with the other stuff. It doesn't take that long to write it out. So it says here. So what's the general relationship for this? We know that distance, and this hadn't changed from physics, equals rate times what? Time. All right, and so we just changed it to distance equals rate times time. Now, that simple equation should help me find time, and it should also help me find rate. Because as long as you know 2 out of the 3 things, should you be able to find it? Yeah. So, what if you want to find the rate? Think about this. If I have distance equals rate times time, and I want to know what r is, what would you do to get r by itself? Divide by what? So rate equals distance divided by what? Time. Oh, really? That's it? Yeah. What if I want to find time? This is my original equation. Distance equals rate times time. How do I get time by itself? Divide by rate. So instead, time is going to equal distance divided by what? Rate. So today, when we're working with this, we're going to highlight these 3 basic equations. We're going to use those formulas to our advantage for what looks like really hard, complicated problems. But if you're willing to organize yourself, but now what you know, you're going to be able to get it. Now, let's look at this one and see if we can apply what we just talked about. If I travel 300 miles in 5 hours, what's my rate? What formula would we use? Yeah. So rate we know is equal to distance divided by time. Okay. So we plug it in. 300 divided by 5 equals. Now what's my label though? Yeah, miles per hour. So MPH, or you literally either write it out, miles per hour, or we go back to our old faithful MPH, which is the understood. MPH, they use that all the time with cars, right? When we're purchasing them and stuff like that. Miles per hour. Now, you didn't have to use that formula. You could have just said, okay, I know this formula is true. Distance equals rate times time. Could be through the fact that I know I traveled 300. I plug in, I don't know my rate, but I know my time is 5 hours. Does it do the same thing? So do you realize just rewriting the formula or just plugging it into the original distance equals rate times formula, does it still get us to the same spot? Yes. Now, what happens if we have more than just one distance, rate, and stuff? Remember, the Jack and Jill problems? Or airplanes going opposite direction problems? All of those, you make a chart. You use the chart to help you fill it out. Okay. Now, You will need to do this on your homework. The reason why we selected and did a worksheet is we really selected these problems for you. You can select the ones like you do with your notes, and you need to set them up the same no matter what. So, what are the steps for doing this? I'm going to read the steps and then I'm going to show you how they work in the problem. Are you guys good with that? All right, so when you're working with this, the steps for solving word problems that use distance, rate, and time. First of all, you set up the chart and fill in variables. What are you trying to solve for? Number 2, fill in one column involving known values from that problem. 3, set up the last column using variable and known value. 4, set up an equation. 2 equal values using the last column filled in. Now someone goes, this is really confusing. Take a deep breath until we actually do it, all right? So until we actually do it, don't freak out. All right, so you notice how I use Jack and Jill as my example? Guess who just came up? Jack and Jill. So we have Jack and Jill. They're traveling to a business conference. Jill travels 110 miles in the same time that Jack travels 140 miles. Jack travels 15 miles per hour faster than Jill. Find the average rate of each person. Now, first of all, do we really have 2 different people we're talking about right now? Yeah, we're talking about who? Jack, and we're talking about what? Jill. Oh, you mean I have one row for Jack and 1 row for what? Jill. Also, we're always going to be setting up our columns like this. Distance equals rate times time. Okay? So one column is going to be distance. One column is going to be what? Rate. One column is always going to be time. Now, what the different columns are based off of what we do first. First, we have to define a variable. Guys, what are they asking us to find first? Average rate of each person. You got to pick one of them to do this with. Doesn't matter which person you do, Jack or Jill, no. But we're going to let it be Jill for right now because ladies first, okay? Works for me. All right, so let's do that one. Let's define our variable. Let x equals the average rate of Jill. Okay, so we're going to let that be an unknown variable. Can I use that to set it up? Okay, so first of all, we set up our chart for the columns. Now, this, by the way, was just step number 1, just so you know. Putting Jack, Jill, distance, rate, times, that was the very first step. Think we're okay? Okay, step 2 is what we're going to do next. It says fill in one column involving known values from the problem. Guys, what do we know? We know the distance. So this time we're doing distance. Guys, how far does Jill travel? Right, 110 goes there, miles. I'm not putting the labels in for the moment, but we should be putting labels in. We know in the long run our answer has to have it. And what else do we know? Yeah, so Jack travels 140. Great. Now, let's see what else that we have on here. It says set up the last column using variables and known value. What does it say here? It says using variable and known value. It says here, Jack travels 15 miles per hour faster than Jill. Do you see why we picked Jill to be our rate, our average rate? Because Jack, we know, is what? Faster than Jill. So what do we put here? X for Jill. What's going to be Jack's rate? You see how all of a sudden this isn't that bad. So now we just literally threw in. Now, guys, oh wait, I just heard this. What's my missing column right now? Time. Okay. What's the time for Jack? Because we know time equals what? Distance divided by rate. Okay. So what's going to be Jack's time? So we know 140 divided by the quantity, what? X plus? Awesome. What's going to be Jill's? is the last column we filled in? All right, so now we set them equal to each other. So here's how this cool thing works. Are you ready? So we go 140 over x plus 15 is going to equal what? 110 over x. Now, scholars, that is a proportion. How do we solve proportions? We do what? Cross multiply, or what some of you call the what?
Butterfly.
Shame on you for calling it the butterfly. But yes, we cross multiply. So we got this. 140 times x equals what? 110, don't forget your parentheses, x plus 15. So what do we do next, my friends?
Oh, you reverse that plus.
All right, now we just go ahead. No, I didn't reverse the plus 15. It's right. I cross multiplied. These two multiply together. Excuse me. These two multiply together. And those two multiply together. Does that make sense? Oops, make sure I erase my x here a little bit. So I cross multiplied, right, exactly what I needed to. Oops, erased too much. There we go. This is where I wanted to go. Right there. All right, now guys, can we solve this equation? Yeah, so this is 140x equals 110x plus what? 1,000 what? Double check me, but I think it's 1,650. Is that right? 1,650? All right, can I subtract the 110x over? So that's 30x equals 1,650. People, do you think maybe we want to have calculators out today? Yes. What do we do next? Divide both sides by what? What's x? Okay, now what did you just find? What's x? All right, so what is Jill's rate? Average rate. Rate is 55 miles per hour. What is Jack's average rate? What do we need to do? It is 55 plus what, my friends? 15. Could you even plug it in here? 55 plus 15 if that made it better for you. That's fine. Equals 70 miles per hour. Now, girls, are we surprised that the guy drove faster than her? No, not at all. Anyway. Now, unless you grew up like me out in the middle of nowhere, and then everyone's fat. All right. Yes, sir.
Do we need to include 55 plus 15?
I want to know where it comes from. Like I said, you could do it up here, and I'd be okay as well. Does that make sense?
Yeah.
I'm just making sure you do this. All right, let's see if we can do this next problem together. Are you guys ready? All right. Basically, I'm giving you a setup for all three types of problems you're going to do. Fair enough? Next one. And we need to go through it fairly quickly, so let's get going. A diesel train made a trip to the repair yards and back. The trip took 15 hours, and the trip back took 18 hours. What was the diesel train's average speed on the trip there if it averaged 35 kilometers per hour on the trip return? All right, so let's see if we can fill this out real quick. So guys, fill out the chart, okay? So when we do it, how many columns should we have? You could say like 3, or you could also say like 4 if you wanted to, kind of like this, correct? Now, what are our values? Distance equals rate times what? Time, okay? What are going to be our rows this time? Last time was Jack and Jill. So trip there and trip what? Yeah. So we have trip there and trip back. Beautiful. What else do we know?
You know the time it took.
We know the time it took. Exactly. The trip took how many hours? There.
15 and 18.
And the trip back took? 18. Awesome. Now, look what it's asking here. It says, what was the diesel engine's average speed on the trip if it averaged 35 kilometers per hour on the return trip? First of all, what's my variable? What's x going to be? No, what is it? What was the diesel train's average speed on the trip there. Guess what I'm going to let my variable be? The average speed on the trip there. So this would be the average speed on the trip to whatever they call it, the what, repair yard? To the repair yard. This is so exact, it's beautiful. Okay, so where do I put that X? All right. Did I have any other information in that?
Yeah, we know the average speed on the return.
Which goes where? Right underneath the X, right? It's how far?
35.
Guys, what got left this time? Oh, our distance got left. How do we find distance? Oh, so distance just equals rate times what? Time. So what's my distance for this one? 15 times what? And what's our value for this one? 18 times 35. Hey, by the way, someone did this on their calculator real quick. What's 18 times 35? What? 18 times 35 should be what? Thank you. That is equal to 630. Okay? Now, it's the same distance there as it is back. So aren't they equal to each other? So what's our equation? Now, you could have written it like this. And is that okay? Because no matter what, where are we going to get to the spot where those two are going to be 15x equals 630? Does it matter if you do it sooner or later? And the answer is no. But you should be able to get there. So then now what do we do next? Yep, 515. What's x going to be? 42. Now what did we just find?
We just found the average speed on the way.
Yeah, so it's got, what is the train speed? The train's average speed going there is what? 42? Right on. Kilometers per hour. Excellent. Be careful not to just instantly go miles per hour or something like that, or miles. No, actually not kilometers per hour. What is it? Hello, I just did that wrong. Shouldn't it be kilometers? Just kilometers, right? Because it's just that. Oh wait, no, it's kilometers per hour. No, it is kilometers per hour. Oh, it's like having that panic moment. Like, did I just tell them distance was? It's been a long day already. It's all good. Yes.
So basically, if it's like a word problem, you have to answer in a sentence like that.
I think it makes you actually answer it better if you do. It is not a requirement, but students who do better because they actually answer the what? Question. Okay, and I know, Caleb, that's what I forced you guys to do and Nick as well, because it makes you answer the question better. All right, let's see if we can get this last one down. All right, so we got Wilbur here, okay? Wilbur left the hardware store and traveled toward the recycling plant at an average speed of 33 kilometers per hour. Mary left 2 hours later and traveled in the same direction, but with an average speed of 55 kilometers per hour. How long did Wilbur travel before Mary caught up? Okay, now, no matter what, should we just set up our chart? All right, so let's set up our chart. So we have our values. So we have our rows, and we know we have our distance row. We have our what? Rate, and we have our time row. And that's the case. No big deal. And then where is going to be our two rows? One person is who? Wilbur. Who's the other one? Mary. Does it really matter which one goes on top, which one goes on bottom? No. They're the same there, Wilbur and Mary, as long as you have the two. Now let's start putting in the stuff we're looking for. Look at the question. How long did Wilbur travel before Mary caught up? What are we going to let our variable be?
Time.
Yeah. How long? Yeah. How long Wilbur traveled? Right? It's traveled with 2 L's or 1. Travels. Let's just say travels, and then we're going to keep it simple that way. Okay. So we know that is time. But now let's see if we can start filling in the stuff that we know. Let's go back to our first sentence. A lot of this is just reading details. Would you guys agree? It says, Wilbur left the hardware store and traveled towards the recycling plant at an average speed of 33 kilometers per hour. So don't we have right here 33? Okay. It says Mary left 2 hours later and traveled in the same direction, but with an average speed of 55 kilometers per hour. Now, quick question. If Wilbur is at a time of X and Mary left when? What is going to go in for Mary's time? Is it +2 or -2? Because she left later. Now, oh look, what column do we have left to fill out? Distance. And we know distance equals what? 3 times time. So don't we know this is going to be 33 times x? And this one's going to be what? 55 times x minus 2, good save. All right, x minus 2. But did they go the same what? Didn't they go the same distance? Didn't they go to the same place? So isn't the distance equal with each other? Okay, so because they went the same location, and she left from the same spot, same what? Distance. So when we do that, we know 33 times x is equal to 55 times x minus 2. All right, guys, do we move sides or do we simplify first? All right, so this becomes 33x equals 55x minus 110. Now what? All right, which is going to give us a negative 22x equals a negative 110. The reason why I don't panic is do I have a negative equal to a negative? Which means my answer is going to come out positive when we divide by that negative. And what did we get for our x? Right? Now, it asks this question. How long did Wilbur travel before Mary caught up? How long?
5 hours.
Yeah. So, Wilbur traveled what? 5 hours. You'd say respectfully? Ooh, that's a good term in there. Good job. I would write it that way. That's good. What do you guys think? Was it really that? No. So how about you start your homework here so I can help you with these? What do you think? A good idea that we use the last 12, 13 minutes to do at least a couple problems? All right, I'll be walking around to help you, my friends. Yes, you may.